Start all over. Okay, so Unit 2, Lesson 3, second semester, 7th grade math. What is the base of a parallelogram? The base of a parallelogram is the length of the side perpendicular to the height. Okay, so what's the meaning of perpendicular? Do you guys remember? I said look for this to find the height. When you have the figure, what are we looking for? Oren. It's going to form a right angle with the base. Do you guys understand? So let's take a look at the next two problems. Find the area of each figure. So for number 2, what type of shape is that? Who can tell me, classify that shape? Give me some vocabulary terms to describe that shape. Glorabelle? It's a parallelogram. Parallelograms, opposite sides are parallel. Okay, so those opposite sides are parallel. And do you remember the formula for the area of a parallelogram? What is it?
It's base times height.
Nice. So the area equals the base multiplied by the height. Okay, so what did you identify as the base and what did you identify as the height?
The base was 10 centimeters and then the height was 7.5 centimeters.
Very good. So the base was 10 centimeters and the height was 7 5/10 centimeters. And then we learned yesterday, or we reviewed yesterday, a method for multiplying by powers of 10, right? So you could have multiplied this out by stacking the numbers, but did you do it that way or did you just mentally figure it out? Okay, and so when you mentally calculated, what did you do?
It was 25 centimeters squared.
Now hold on a second.
Oh, did I do wrong?
Are you doing number 2 or are you doing something else?
Oh, wait.
Number 2.
Yeah. Wait, hold on.
10 times 7 5/10. There's a shortcut. Can somebody help her out with the shortcut?
I know.
What is it?
It's 7.5. Wait, no.
Well, that's the same one. We need to change it.
750, I think.
You moved it how many places? 2 if you had a 750, but we don't move it 2 places. How many places do we move it? How many zeros are in 10? 1. So we're moving it 1 place. So what's the answer? 75.
Oh.
It's okay. 75. And what's the units going to be?
Centimeters squared.
Centimeters squared. Okay. So you see this shortcut coming up again and again. Okay. Know it. It comes up often in math. Okay. The next one. Olamide, could you get the next one, please?
The area, since for area you have to find many times width, you would multiply 15 times 9, and that will get you 130.
Before you give me the area, can you tell me what type of shape is this?
Rectangle.
A rectangle. Do you remember the definition of a rectangle?
Yeah.
What's the definition of a rectangle?
Length times width.
No, that's the area of a rectangle. What's the definition? How do we know we have a rectangle? There's a certain quality we look for, and we know it's a rectangle.
4 sides.
It's a quadrilateral, yes,
4 right angles.
and 4 right angles. Nice. So a quadrilateral has 4 right angles, right? Is there anything else about the sides for a rectangle? Is there anything else? Opposite sides are parallel, so it's also a parallelogram, right? Okay, very good. All right, so what did you identify as the base?
Base was
15 meters, very good. And what was the height?
19 meters.
9 meters?
9 meters, sorry.
Okay, and then what did you find the area to be?
100
135, and you got the units right. Everybody got 135? Yes. Okay, very good. All right, so pretty easy. Sounds like most of you know what's going on with the area of a parallelogram. Today we're going to cover the area of a trapezoid, and the thinking's very similar. So what you'll learn, to find the area of a trapezoid and the area of irregular figures. New vocabulary, base of a trapezoid, height of a trapezoid. So we need to figure out what the base is and what the height is. So why learn this? If you know how to find the area of simple figures, you can find the area of irregular figures, such as the area of a backyard deck. The formula for the area of a trapezoid follows from the formula for the area of a parallelogram. So if you take a look, here we have a trapezoid. Remember, a trapezoid is different than a parallelogram, right? A parallelogram has two pairs of what? Parallel sides, right? So opposite sides are parallel, but a trapezoid only has one pair of parallel sides. And those are the sides we call bases. Do you understand? Okay. So I feel like a trapezoid is a little bit easier than the other ones to identify the bases because it's the two sides that are parallel. Got it? There's only going to be two sets. Those are the sets that are bases. But there's something else going on here. So the formula for a trapezoid, a little bit more involved than the formula for a triangle or the formula for a parallelogram. Let's take a look at it. So two parallel sides of a trapezoid are the bases of the trapezoid. That's what I just said. Now, we don't want to call the base B because there's two bases for a trapezoid. So we have subscript, do you see that 1 there? Subscript 2. So the bases of the trapezoid with lengths base 1 and base 2, the height of a trapezoid, h, is the length of the perpendicular segment connecting the two bases. Do you guys understand? So if you put two identical trapezoids together, you get a parallelogram. The area of a parallelogram is, so how do I figure out the area of a trapezoid? Well, we don't have a formula for that yet, okay? But we can figure it out because if we double that, this is the same, I just took the same parallelogram, right? The same one, right? It's the same shape. Now I'm going to rotate it, and I'm going to line it up so that I have a, what shape did I just make? Now I have a parallelogram. Parallelogram, a rectangle can be is a parallelogram, but not all parallelograms are rectangles. Remember, opposite pair of sides are parallel. So we know how to find the area of a parallelogram, right? We just did it. What's the area of a parallelogram? Base times the height, right? But I just took a trapezoid, and what did I do to make this parallelogram? I doubled it, right? So if I wanted the area of just the trapezoid, what would I do? Think of my formula. It'd be half the area of this parallelogram, right? But remember, what's the base of this parallelogram? I heard it. Somebody said it. It's not just base 2. That's part of that. If I take base 1 plus base 2, that's the base of the parallelogram, right? So now I want you guys to understand the formula. So the base of this parallelogram I made out of two trapezoids is base 2 and base 1 added together, multiplied by the height. That would be the area of this entire parallelogram, right? But if we want the area of the trapezoid, we would just take half of that. So do you guys see the formula? The area of one trapezoid equals a half base 1 plus base 2 times the height. Do you guys understand the formula now? So I'm trying to get you guys away from memorizing formulas, and I would like for you just to understand where the formula comes from. Does that make sense? Yep.
Can't you just say like half the height times base 1?
You could say half height divided by 2 times. That's another way to look at it. There's a couple ways, but do you understand this formula? So just like the other formula for the triangle, there's a couple ways it can be written out, okay? All right, so the key concept, area of a trapezoid. The area of a trapezoid is 1/2 the product of the height, h, and the sum of the bases, sum of the length of the bases. So that's where we have this formula right here, okay? And so Ola made a good point. He said, couldn't I just take h divided by 2, and then multiply that by my bases that are summed together. Yeah, that's another way to write the same thing. Just like we did for triangles. I showed you a couple ways to think about the formula, right? Okay? So let's move along. All right, you can estimate the area of a state of states shaped like trapezoids. Well, let's find the area of this trapezoid shown. And let me see. All right, well, before we figure out and estimate an area of an irregular shape, like the area of a state, let's take a look at the area of this trapezoid. Let's practice finding the area of this trapezoid. Can you guys do that? Remember the bases of a trapezoid are what? How do we know which sides of a trapezoid are the bases? Olamide said it. Can you say that a little louder, Olamide? They're the parallel sides. So I've already given you a heads up. Hey, they're going to rotate these pictures around, try to throw you off. So half the battle is figuring out what's the base, what's the height. So would somebody mind sharing with me what they identified as base 1 and base 2? Fatima.
It's 8 and 5 centimeters.
8 and 5/10 centimeters. That's one of my bases, yes? And 13 and 5/10. So really quickly, I'm just going to rotate this. So it looks like what we had in the formula. Do you guys see that? That's my bases. Okay? And just from looking at some of the expressions, it made sense once I rotated it, right? Okay, can I rotate it back? All right, I'm going to rotate the picture back. All right, and so it doesn't matter which one I identify as base 1 and base 2, but these are my bases, right? And the reason why it doesn't matter which one I identify as base 1 as base 2, because I'm adding together. The order that I add two numbers doesn't matter. All right, so in my formula, base 1 is 8 and 5/10, and then base 2 is 13 and 5/10. Okay, and we're going to take the sum of those two numbers. But is that everything to find the area? What else do I need to identify? H, right? Who can tell me what the height is? Timothy, what's my height? Very good. My height is 15 centimeters. Over here, 15 centimeters. Okay. And then all that is multiplied by 1/2. Okay. All right. Would somebody mind telling me? Let's simplify what's in my parentheses first. Who took the sum of 8 and 5/10 and 13 and 5/10? What'd you get? Well, what's 8 and 13? We can do this mentally. What's 8 plus 13? 21. And then 0.5 plus 0.5 is what? 1. So if we have 21 and we add that half and half together, we have what? 22. So the two bases added together are 22. Now, mental math, ladies and gentlemen. If it's easier to take half of 15 or half of 22, or remember the order of multiplication doesn't matter, right? Okay, so do whatever is easiest for you. So I'm going to tell you who multiplied in order from left to right. So you took half of 15, what'd you get? 7.5, and then did you multiply that by 22?
Yes.
What'd you get? 165 centimeters squared. Is that what you guys got? Well, what about this? Couldn't I have said, hey, what's half of 22? What's half of 22? 11. And then 11 times 15, well, that's 150 plus 11, right? And that's going to be the same thing, which is what? 165 centimeters squared. And I dropped off the units, but I shouldn't have. But you guys see why it's centimeters squared? We're talking about area. Okay. Glorabelle, do you have a question? Yes, go ahead. Timothy. When she gets back, you can go. All right, so moving right along. What I need you guys to do now is find the area of these two trapezoids. Do you see the formula right there? Okay, we're not squaring anything. We're taking, what are we taking with the bases? Those little numbers say that I have two bases, the first base and the second base. So they're small, they're called superscript. Exponents are, they're called subscript. Exponents are superscript, they're up in the air. Subscript just means, hey, these are two different b's. Who would like to share with the class how they found the area of the first trapezoid? So here's my formula up above. Area equals 1/2. First of all, what's the height? Who identified the height? Can I get a volunteer to tell me what the components of the equations will be? What are we going to substitute into my equation, my formula? Tayana. 4 6/10 meters is the height, right? And I'm going to definitely put in the units this time. And then we have to worry about our, that's not the entire formula, we have our bases, right? So we have to take the sum of our bases. What's my two bases?
So the first one I put was 9.5 meters.
9.5, 9 5/10 meters. Okay, and the other one?
6.
Very good, 6 meters. So I just wanted to do check-in. Did everybody get to this point? You substituted into the formula the correct values. So you had to identify the bases and identify the height, and then you had to substitute it into the formula. So did everybody get to this point?
Yes.
Now it's just a matter of can you perform the calculations. So let's go ahead, and we need to simplify what's in the parentheses first, because we're going to try to follow order of operations. Okay? So when I take the sum of these two numbers, what do I get back?
15.5.
Tayana, what'd you get back? What'd you get?
I got 10.1.
Well, what's 9 plus 6?
11.
9 plus 6? Look at where my decimal is. That's a whole number. That's not a decimal, okay? So just look at the whole number 9. 9 and 6 is what? Yep, you got it. 15, okay? But then I have to add that 0.5, so it's going to be 15.5, okay? Now, if you were to take it and add it like this, remember you have to line up your decimals? There's no decimal on that, so you would take and add it. That's a 5, bring your decimal down, and then you get 6 and 9, that's 15, okay? All right? So, we see that once we simplify what's inside the parentheses, we got 15.5 meters, okay, and that's all multiply. And now we can go ahead and find half of 4 6/10. What's half of 4 6/10? Well, that's pretty easy. What's half of 4?
2.
What's half of 0.6? So, or you could have multiplied that by 0.5. Hey, how you doing? Who's that? Yes, yes, he is. So if we take 4, or you can think about this, if you want to think about this like money, $4.60. What's half of $4? 2. What's half of 60 cents? 3. Right? So 2.3 meters. And now I got to multiply that by what I have up here for my bases. Did everybody get to this point? Okay. Now this is review. We have to know how to multiply, right? And multiplying is a little different than adding decimals. When you multiply, you take care of the decimal at the end, right? So let's go ahead and walk through this. 3 times 5? 15. Carry the 1. 3 times 5 again?
15.
Plus the 1? 16. Carry the 1. 3 times 1? Plus the 1? 4. Now before I multiply the 2, I got to do what? I got to put a 0 down here. And now I'm going to go ahead and multiply the 2's. 2 times 5
10.
is 10. Carry the 1. 2 times 5 again?
10.
Plus the 1? 11. Carry the 1. And then 2 times 1?
2.
Plus the 1? 3. Now I need to find the sum of all these things. And then I got to place my decimal, right? Move this picture up a little bit so we have some space. Okay, so we have 5 and 0, which is
5.
6 and 0,
6.
4 and 1,
5.
and then 3 with nothing?
3.
3. Where's my decimal going to be?
Between
Between how many places am I going to move it from the end? Who said 1? Shh. Look, right here is 1 place and then 2 places. So 1 and then another place, that's 2 I have to move. So 1, 2 places. So my answer is going to equal, and remember we got to have our correct units. What's the answer going to equal? What's the units? Just when you get back. Units, ladies and gentlemen, we're talking about area. Meters squared. Okay? All right, let me shrink this down and get this out of the way. Okay, here's my calculations. Okay, here we are over here. This one. How do we figure out the area of this trapezoid? Who can walk me through this one? So the formula is still the same. Area equals 1/2. Who's got the base? What's the base of this trapezoid? Or what's the height of this trapezoid? Can I get a volunteer explaining this to me? Alexis.
So the base is
Well, we want the height first because that's the first thing.
6 meters.
6 meters, good.
And then the base is 27 meters because you added.
Right, so you gave me the sum of the bases, and so, but can you tell me what the bases are? Because not everybody is able to do that mentally. So what's one of my bases?
21 meters.
21 meters is one of the bases, correct? What's the other base?
6 meters.
6 meters, good. 6 meters. Okay, so we need to take the sum of those. All right, so let's go ahead and we'll simplify the sum. And so what is the sum of that going to be? You just gave it to me.
27 meters.
Good. 27 meters. Okay, and then we have half 6 meters times 27 meters. So let's simplify this further. What is half of 6 meters going to be? 3 meters. Good. Okay, and then I have to multiply that by 27. What's 3 times 27 meters? 81 what?
Meters squared.
Meters squared. Okay, any questions about this example? Everybody understands how to identify the parts and use the formula? We have a quiz on Monday. For these two problems. Okay. Now, what I said earlier, you can estimate the area of states shaped like trapezoids. So if you look at Arkansas, it kind of looks like a trapezoid. So even though it's not a perfect trapezoid, we can still estimate how many square miles the state of Arkansas has. Okay, so let's estimate the area of Arkansas. Here's the picture. I know it's a little fuzzy, but can everybody see the measurements? Yeah. Okay, really quickly on your own. Let's do an estimate. Yes, she's on her way. Okay, can somebody tell me what are the bases of this trapezoid? Can I get somebody to volunteer I haven't heard from yet? Caleb, give me the bases.
The bases are 190
And?
250.
250. Those are my bases. So, and what's the height going to be?
242.
Okay, 242. So let's plug that into our formula. So we got 242 miles for my height, and we're going to multiply that by half. And then I also have to take the sum of my bases, and you just told me that 190 miles plus 250 miles. Okay. So let's go ahead and calculate this out. What did you find was the sum of the bases?
So that is 440.
So you found that to be 440 miles. Okay. And then we still have to worry about half 242 miles, right? What did you find was half of 242 miles? That's something you can mentally solve, right? Right, so this becomes 121 miles. And now I need to multiply that to the sum of the bases, which you said was 440 miles. And what did you get for that?
53,240 miles.
Did you guys get the same thing?
Yes.
Say again, 53 what?
53,240
240 miles?
squared.
Very good, squared. Okay, I'll take your word for it. Let's move along. All right, estimate the area of the figure at the right by finding the area of the trapezoid. So again, we have this figure. It's an irregular figure, but we can estimate its area by finding the area of the trapezoid. Okay, who can walk me through this problem? You know, the area is 1/2, the height, and what is the height? Who can walk me through this? Somebody I haven't heard from yet? Rudy, can you walk me through this? What's the height of this trapezoid?
The height is 3.5 inches.
3 and 5/10 inches. Yep. And then we need to multiply that by the sum of our bases. So what are the bases? Very good. So we have the bases are 3 inches and 2 inches. Okay. So let's go ahead and simplify this a little bit. What's the sum of the bases going to be?
5 inches.
Right, so we got 5 inches. Okay. And then we need to take half of 3.5. Did you get the half of that? Well, this is all multiplication, so if you wanted to, you could mentally do this in a different order. All right, I could have multiplied a half times 5 and then multiplied that by 3.5, right? So, but just for the sake of review, a half is the same as what as a decimal? 0.5. So we're really taking 0.5, and we're multiplying by 3.5, or 3 and 5/10. So let's go ahead and multiply that out. So 5 times 5 is going to be what?
25.
That's going to be 25. Carry the 2. 5 times 3? 15 plus the 2? 17, right? And then we don't really need to multiply the 0, but we do need to account for my decimals, right? So I have a place here and a place here, so I got to move my decimal to where? Between the 1 and 7, so it's right here. So 1 and 3/4 are 1 and 75/100 inch. Well, now I got to multiply that to 5. So let me go ahead and move this out of the way. Okay, I'll move this right here. And so if we take 1 and 75/100 and we multiply that by 5, let's see what we end up with. 5 times 5? 25, carry the 2. 5 times 7? 35 plus the 2? 37. And then 5 times 1? Plus the 3? 8. Where's my decimal going to be at?
Between the 8 and 7.
Very good, between the 8 and the 7, because we have no place here, 2 places here, so it's going to be 2 places in. So that means my answer is 8 and 75/100. What units? Inches squared. Nice. Okay. Any questions about how we found the area of these trapezoids? Okay, we are almost done. Question, yeah.
So, like, on the test, do you have to do it that way, or you can, like, do it?
Well, remember, commutative property of multiplication says you can change the order. If everything is multiplication, you can change the order around and multiply it. And how many of you guys did it multiplied a different order than what I did on the board? Did you get the same answer? Because that's the commutative property of multiplication. We can change the order around. All right, so the perpendicular distance between two parallel sides of a trapezoid is called the blank of the trapezoid. What is it, class? The height. Come on. Come on. All right, so identify the bases and the height of each trapezoid below. So they don't want you to find the area. They just want you to find the bases. So for the first question, base 1, base 2, and the height. Okay. And I want to know what those are equal to. So we're almost finished. Let me go ahead and copy these for the other ones. Okay. Okay, so for this first one, what is the first base? Who can tell me what that is? Give me a base. Olamide. Six what?
6 meters.
Meters. Somebody give me the second base. Abu. 9 meters, right. Somebody give me the height of this rectangle. Laura Bell. 3 7/10. Is that perpendicular? Remember, it's got to be perpendicular. It's got to be at a right angle to the bases. So which is at a right angle?
3 6/10.
You see how they're going to trick you? They're going to throw the extra stuff in there. So 3 6/10 meters. Good catch. Okay, so just to make sure you have it, I'm going to give you the next one. Tell me the height of this one over here.
10 inches.
Nice. Okay, so now you definitely know it. So 10 inches. Okay, can I get somebody to tell me one of the bases? Can I get a volunteer? Alexandra? 8 inches is a base. Good. And can somebody tell me the other base? Rudy? 2 7/10 inch. Very good. And then for this last shape up here, can somebody tell me the base, one of the bases here? Fatima? 4 feet is a base, yes. Okay. And then can somebody tell me another base? Snowden? 7 feet. Nice. 7 feet. Okay. And then can somebody tell me the height? Logan? 4 feet. Very good. Okay. Now, I'm not sure how much time we have, but I do want to go to yesterday's quick check because a lot of you were thrown off by this. So remember the area of a triangle. What is the formula for the area of a triangle? Some of you guys are just kind of talking. It's 1/2 the base times the height. That's one way to think about it. Or the base times the height divided by 2. So can somebody please tell me what the base is? 4 2/10, right? And can somebody tell me what the height is going to be? Okay, so if we multiply 4 2/10 times 5 5/10, a number of you did not do very well, and I need you to listen. I'm trying to go over the solution with you. So 5 times 2, 10, carry the 1. 5 times 4, 20 plus the 1, 21. Now I need to do what? Place value holder. I'm going to continue multiplying this. So 5 times 2, 10 again, carry the 1. 5 times 4, 20 plus the 1, 21. So we're going to add all this up now. So I got 0, 1, 3, 2. Where's my decimal going to go? Now, are we done? No. What did I just find the area of? A rectangle. The rectangle that would be double this triangle, right? So I got to find, and do you guys notice that that's one of my choices? So if you looked at this and said, oh, that's one of my choices, do you see how they're trying to trick you? Do you guys understand? Okay, so you're half a step to getting the right answer, no pun intended. What's half of 231, 223 and 1/10? What's half of that? Yeah. Okay. Can you tell me what the base is on number 2? Okay, and here's the height. I'm going to color code it. Now, this one, I wanted to go over this one. Now, listen, what is the base of this triangle? This is what tripped up some people. It's not 3. It is the distance all the way across. So the base equals 6 inches. Okay? And what's the height going to be?
7 inches.
The height is 7 inches. All right, I'm not going to work this out, but do you guys see how they're setting you up? Okay. Shh. But this is how they determine who just has a basic level understanding and who has a more advanced level. Do you guys understand? So I'm trying to get you guys to where you're not going to be tricked by the more difficult problems. All right, so find the height of a triangle with area 110 feet and a base. So guess what they're giving me? They're giving me the formula is area equals 1/2 base multiplied by the height, right? So we have to substitute what we know. Well, what do we know here? The area we know, right? How much is the area? 110 feet squared. Okay, 1/2, that's part of the formula. Do we know the base? Yes, we know the base. The base is how much?
10 feet.
10 feet. So let's put that in, 10 feet. Do we know the height?
No.
So I'm just going to put h there. I don't know what it is. I'm going to leave it. Well, what's 1/2 of 10? 1/2 of 10 is going to be 5 feet. So 110 feet squared equals, when we simplify this becomes 5 feet, right? Well, 5 feet times h, what times h? H times 5 gives me 110. What is that going to be? How would I solve that to get h by itself?
Divide.
Right, I would divide both sides by what? By 5. So let me shrink this down, move this out of the way. So if I divide both sides by 5 feet, 5 feet. My 5's cancel, that gives me my h. And then here it's just long division, right? 5 goes into 110. Well, 5 goes into 11 how many times? 2. 2 times 5 is 10. I subtract, I get 1. Bring down my 0. How many times 5 go into 2? 2. So guess what it's going to be? 22 feet. Okay? And then, oops. The last problem. The area of the parallelogram. They're telling you what the area of the parallelogram is. What is the length of the base of the triangle? Okay. For this one, we need to know the formula for the area of the parallelogram, right? What is it? Base times height. So the area, and I'm just going to draw area of I'm going to draw a little parallelogram, equals the base times the height, right? Okay, and so we know that the height is 200, or 20 and 5/10, and we know the area. So let's go and replace that so we can figure out the base. So we want to know what the base is going to be, right? So length AB is also length DC. So is it possible to figure out the length of the base of the triangle? Because DC is congruent to AB. So basically what you would do is you would solve by replacing the area of the parallelogram, which is 246 millimeters squared, and that's going to equal, do we know what the base of that is? Nope. But we do know the height, and the height is going to be 20 and 5/10 millimeters. Now, you can solve for the base to get the base of the parallelogram, and that's also congruent to the base of the triangle, right? So how would we solve this? Divide by what? 20 and 5/10 millimeters. 20 and 5/10 millimeters. And then guess what cancels out? That cancels out, that cancels out. And then if you actually divide that out, since we're short on time, I'm going to go ahead and just crank this out for you. How are we looking on time? Who's got a watch handy?
It's 9:24.
Okay, so when I divide this out, guess what this equals? 12 equals B. And was that one of my choices? Here it is. Okay,